It's question show time. Your questions, my answers, as always, wherever you are on my channel. Question pops into your brain, write it down, I'll gather them up, and I will answer them here. Not surprisingly, a bunch of you had a bunch of questions about Mars. Pierre Van Obergen. Dear Fraser, I'm a huge fan of your So Good Job. I can't wait for the next episode. But come on, those stories of building factories on Mars is so out of reality. We are so far away from this. We haven't put a simple feet on the ground of Mars. Then talking about building factories, maybe in 200 or 300 years, but out of reality now. Just try to lift one wheel of your car above your head and you understand the problem. Gravity makes it hard for us to escape heavy material from Earth. Then sending so much stuff, machinery up there is just completely out of the question for the moment. Don't you think, Fraser? I don't know whether I can win. On the one hand, I tell people that Mars is just incredibly complicated to go to and that it's going to take a lot of resources for us to be able to set up on the red planet. And then on the other hand, if I sort of explain the ways that we might, then people think it's being unrealistic. Now, of course, my take, right, is that gravity wells are for suckers and that the future lies in space itself. But we'll get more into this as we go into the episode more. The purpose of that video was to just talk about just the general resources that are available on the red planet. And various resources will be useful at various times of us exploring and maybe settling Mars. So in the very beginning, in fact, the Mars 2020 rover is going to be equipped with a device that's going to be pulling oxygen out of the atmosphere of Mars to try and see if that's possible. When the Mars sample return mission goes, which ESA just announced they're moving forward on this, the return rocket that's going to be sitting on the surface of Mars will probably use some method of pulling in atmospheric carbon dioxide, mixing it with either hydrogen that they bring or water, and trying to make fuel for the return flight. And when Starship actually starts to land and there's going to be return flights, they're going to be heavily relying on building fuel locally on Mars. So that's like the first step. And then as you get more and more infrastructure on Mars, then it makes sense to gather up more and more of your stuff using the regolith, pulling the regolith apart to use it for various things. So this is like a process where you start with the simplest possible chemicals that you can pull out of the Martian environment to make your life a little bit easier to get to, explore, and return from Mars. And then over time, as there's more and more infrastructure on the red planet, then it makes sense to go farther and farther. And eventually there will be so much infrastructure that Mars will be a completely self-sufficient, completely independent place from Earth. Or not, but that's the direction that Elon Musk and SpaceX wants to go. So I think it's like this process of saying, what's possible? And then you sit down and you do some research and you do some thinking and you talk to each other and you express these ideas, and then people will question certain facets of it and technology will be developed and it will test things out and we'll find out. And so I think it's really important, some things are going to be realistic and some things are going to be unrealistic, and we don't know which ones they're going to be until we try, until people make these attempts, and then we're going to find out what's going to happen and what's not going to happen. But I'm not looking to necessarily decide in advance what's going to work and what's not going to. I know that for me personally, I want to live on Earth. I don't want to live on Mars. But there's a lot of people that do want to live on Mars, and they want to go through all of that hardship to make it possible. So, and more power to them. I can't wait to see what they discover, what they uncover, what incredible techniques they develop, and we here on Earth will support them with all of the technologies and all the new developments in material science that we can to make their life possible on Mars. Back in the USSR 18. Hey Fraser, are all galaxies in the local group gravitationally bound? And if so, will they all eventually merge together? Thanks. Yeah, all the galaxies in the local group are gravitationally bound. And so when we think about the local group, we think about the Milky Way, we think about Andromeda, we think about M33. Those are the three big galaxies. And then you've got dozens of dwarf galaxies that are all spinning around. And eventually, in the, over the next tens of billions of years, all of these galaxies will come together and they will form one single giant elliptical galaxy. And then there may be other other galaxies that are just outside of the local group that are still gravitationally bound to us, or we're gravitationally bound to them, and we'll all fall into some larger structure over time. And then eventually there's this point where the expansion of the universe, and perhaps even the acceleration thanks to dark energy, is going so fast that those galaxies will never have a chance to actually fall in and collect together. And so when, say, astronomers talk about these gigantic structures like Laniakea, which is like 1 billion light years across, the reality is that the expansion away of all of these things means they're never going to actually fall together and become a single thing. They are impacting each other gravitationally, but the expansion is the dominant force at these largest scales. But at the local area, eventually we, Andromeda, M33, dwarf galaxies will become one giant elliptical galaxy. John Gallant. Hello, Fraser. With the advances in technology around gravity waves, will there become a time when the detectors can predict a merger well enough in advance to alert all the other observatories, like in 30 minutes, look at this region? One of the most incredible things about the discovery of the kilonova, that was these two neutron stars that spun around each other and then they collided. Well, one was that we saw the burp of gravitational waves as they were just about to collide, and then the moment that they did, we also saw the flash of radiation at the same time. And that proved once and for all that gravitational waves and electromagnetic radiation, light, move at precisely the same speed, the speed of light. But incredibly, right, we saw this buildup of gravitational waves, this chirp, as these two neutron stars were spinning around each other, and just seconds before they actually collided, they were causing so many gravitational waves. That's what astronomers were able to detect. So you can imagine some time where the gravitational wave detectors get a lot more sensitive. Instead of being able to only detect the waves in the last couple of seconds, maybe they can detect them in minutes or hours or days. And you could get to this point where you can inform the visible astronomers that an event should be observable in this region of the sky. Turn your telescopes, wait, there it is. And maybe even, say, with colliding black holes, maybe it's invisible, but maybe there's radiation swirling around them, and maybe that radiation collides, the accretion disks of material around the black holes as they come together, and that releases a flash of radiation, and maybe that's a way that astronomers could confirm gravitational waves or colliding black holes, things like that. So there's a ton to be learned, and there's tons of advancements in this high-speed astronomy that gets done. One of the most fascinating instruments out there is this thing called SWIFT, and it's a gamma-ray observatory that scans the sky all the time on a regular basis, and the second that it detects a gamma-ray burst anywhere, it turns and then observes the gamma-ray burst, because you got to act quickly. And so I'm really looking forward to sort of the new gravitational wave observatories extending the period that they're able to detect these impacts, and then the collaboration between gravitational waves and other forms of astronomy, this multimodal form of astronomy. It's a really exciting time to be watching this stuff evolve. K. Tarab. Could there ever be a day when we can live on Mars in regular houses like we do here, or will we never be able to change the atmosphere so we can't live there like we live here? Obviously, we don't want to say never, because who knows what kind of amazing magical technology we'll have in the future to remake the universe however we see fit with our godlike technical abilities. But in the near term, Mars is just terrible. And it has a fraction of the atmosphere that the Earth has. And so you just couldn't live outside without some kind of protective bubble, spacesuit, dome, whatever it's going to be. And we could theoretically thicken the atmosphere over long periods of time, this idea of terraforming, but it requires geoengineering at a scale that we can scarcely comprehend, and it's going to take hundreds, if not thousands, if not tens of thousands of years. And the solar wind from the sun is constantly blowing away Mars. So any thickening that you do of the atmosphere, you're going to be fighting against this solar wind that's attempting to blow it all back off into space again. So got your work cut out for you to be able to live outside. And that's kind of not the point, I think, right? Like, if you want to live outside, how about Earth? Earth is great. It's got air, you just breathe it. Sunlight, water, birds. I think that Mars is going to challenge humanity to live in different and new ways that we don't live here on Earth. Bork, bork, nom, nom. Love your content, Fraser, but serious question, isn't mining the Earth of its minerals and producing plastics something that we shouldn't be doing? But now talking about going to Mars, doing exactly that, it's super confusing. I'm all for going to Mars, but understand that mining is going to be part of the long-term habitation. Part of the question is whether or not there's any life on Mars at all, right? If there is life on Mars, microbial life, then we're going to need to decide how much of an impact we're going to cause. There's some camp of people that are like, who cares? They're just microbes. Grind them up. We'll make some kind of tea out of them. And there's another camp that says it's a completely separate life form that evolved in its own particular ways, and we need to study it and understand it and try to prevent and minimize the impact that we have on that life. My guess is the former is what will eventually win out, because that's just kind of how we roll as human beings. If Mars is dead, completely dead, that there is no life on Mars, then it's just a rock, right? Like a big rock, a lot of rocks combined together, and it has sort of its aesthetic value as these beautiful landscapes and valleys and incredible geological history, but I don't think there's any necessarily moral reasons why we shouldn't grind it up and turn it into cities and tunnels and farming equipment and whatever we decide to do with it, right? I think there's a really good case, just from an aesthetic plan purpose, to just leave giant chunks of the solar system that are geologically interesting, beautiful, untouched, to turn them into wildernesses, right? To turn the moon and Mars and parts of the moons of Saturn and Titan and things like that, just leave them as wilderness. There's no real need to get at their minerals. There's tons and tons and tons of just raw resources in terms of asteroids all around the solar system, and they are not in any pesky gravity wells, so they're very easy to get at relative to a place like Mars. But we're just going to have to find out what we decide to do, and then eventually in like 5 billion years, the sun will cook all life on Earth, and all will be destroyed. So really, it's just like when you want to destroy that stuff, sooner or let the sun do it later. Virginia Hansen. Question, you said Earth moving equipment, but shouldn't it be Mars moving equipment? Or yeah, how do we deal with the word Earth on other planets in context when we aren't referring to our home planet? It depends on how much of a nitpicker you want to be about using this terminology, right? The precise scientific term for the stuff on Mars or the moon is regolith, and that's just ground up rock. And then here on Earth, the ground, the dirt, the soil is ground up rock, but also bacterial life and decaying plant matter and other stuff that makes it a medium for growing plants. But I mean, we're just like, there's the moon and then there's other moons, there's the Earth and there's other Earths, and language is a funny thing. So I think that if you have to decide which hill is the one you want to battle on, and trying to make sure that people don't call regolith on Mars dirt is not the one that I want to fight. I've got other battles. So let's call it dirt. We'll call it Earth. The rich, loamy Martian Earth, which is super confusing to say, but people will know what we're talking about. Jace555 UK. Hey Fraser, love the channel. I was wondering, when the moon first formed, what are the chances that it has an atmosphere, even if it's just a primitive one? The moon is very small, and the moon doesn't have a lot of gravity to use, and it's also relatively close to the sun, like the Earth. So the constant solar wind that's blowing off of the sun will be grinding away at the atmosphere of the moon. And the moon, if you like took a nice thick Earth-like atmosphere and just gave it to the moon today, it would be able to hold on to that for about 10,000 years. And then the solar wind would have blown away all of that nice atmosphere, and you'd have to start again. So really, even if the moon did have an atmosphere at any time in its history, the solar wind blew it away a long time ago. Now, the moon does have like a really tiny atmosphere, but it's mostly like particles from the sun that have been captured into orbit for a brief period of time, or chunks of rock that have been blown up like dust into the surrounding environment, or material that's held aloft by magnetic field, or as sort of static electricity as it moves across the surface of the moon as it goes from day to night. But there's no real permanent atmosphere there at all. And if you gave it one, it would lose it very quickly. But 10,000 years, I mean, that's not terrible, right? If we replenish the entire atmosphere of the moon, then every 100 years or so we'd have to give it a bit of a top up, and that all that time the moon would be a habitable world, which is kind of a neat idea. Federico Fudio, what are the odds of finding liquid water at the edge of the polar ice caps? Liquid water? None. There is the only place that you're going to find liquid water on Mars is deep, deep, deep underground. And in fact, it has been found. So recently a spacecraft observing Mars detected evidence of a vast lake underneath the surface of Mars, but like about 1 kilometer down. And it's probably some kind of brine, with a lot of salt in it so that it can handle being liquid at a lower temperature. But on the surface of Mars, liquid water just can't exist. The second it comes in contact with that lack of atmosphere in the environment, it's going to sublimate and just turn into water vapor. And then the solar wind from the sun is going to blast that water vapor out into space. So no liquid water on the surface of Mars anywhere to be found. BigCuda.com. So is it physically feasible to exist on Mars using resources there for a scientific mission of several people, which could be funded by global resources for a short period of time? Beyond doing just science with limited funding available, can a large Mars base be capable of housing hundreds of people and be economically viable? What could it produce and trade with Earth in order to repay those who invested in a large expense of building such a base? I'm scratching my head. Where's the business model here? There is no business model for living on Mars. It is an expense, and it will continue to be an expense. It will be funded by Earth for as long as it takes for the planet to become self-sustainable. And that could take hundreds of years. It's going to require constant resupplies. It's going to require people going. It's going to require machinery and technology and logistics back here on Earth to support that. And it will be that case until it's not. And we don't know when it won't be. So, a lot of people are talking about the potential of manufacturing in space, or mining in space, or power in space. But all of those really are going to be expenses that there's no way that you're going to be able to make money in the short term, medium term, possibly even long term, in any way, shape, or form. That we go out into space because the expense is worth doing, that it's worth taking that on for us to understand and conquer the next frontier. And that's why so many companies that have attempted to try and do space mining or all kinds of things, they have all gone out of business because it's just too expensive. It is a cost. And if you don't have a way to make money from it, there's no way to sustain your business over the long term. But eventually, when there's enough infrastructure in space, people will figure it out, and it will stop becoming an expense, and it will either just not be an expense, it'll be self-sustaining, or there will be some way that it becomes a profit back on Earth. I don't think that it will ever become a profit back on Earth. It'll just stop being an expense because it will be able to take care of itself. And that's what we have to hope for if you're going to invest in space. Making sense. Well, the biggest stumbling block was mentioned in passing and totally ignored otherwise: nitrogen. Mars is really poor in nitrogen, so any substantial settlement will need serious supplies of it. What are the core elements of life? Carbon, hydrogen, oxygen, and nitrogen. So that is something that needs serious attention. Yeah, I mentioned briefly in that video that there seem to be trace amounts of nitrogen that make their way into the atmosphere, and so there must be some deposits of nitrogen on the surface of Mars. Maybe there's going to be underground. It's going to be a tough one to get. And here on Earth, with what, 70% nitrogen in the atmosphere, we just pull it right out of the, we're breathing it right now. We just bring it out of the atmosphere and we can just turn it into fertilizer and all kinds of things. And that's going to be really tough on Mars. And it might be that for the medium term, we have to import tons and tons of nitrogen from Earth or comets or asteroids or something like that. And maybe they can develop a closed environment where they hold onto that nitrogen really carefully and they don't burn it and fire it off into the atmosphere, and they realize that it is a very precious resource. Different elements on Mars are going to be more or less valuable than they are here on Earth. It's sort of hard to think about just how much this planet is doing for us all the time in terms of the atmosphere, in terms of the rock cycle and the carbon cycle and the water cycle, all the stuff and all the life. This is all, we get all this for free. And we take it all for granted. And when we go to a place like Mars or try to live in space, we're going to have to manufacture each one of those completely independently and make it self-sustaining, which is going to be a real challenge. We need to spend more time learning how to work a completely closed cycle environment before we stand a chance in being able to survive on Mars for any length of time. And it'd be weird, right, if the colony failed because they ran out of nitrogen. So, so more nitrogen on Mars, please. Dan knows. So what do people need to bring with them from Earth? It's going to change over time. In the beginning, as people go or as robots go to Mars, they're going to need to bring everything, right? They're going to need to bring all of the equipment, all their technology, and even, say, tanks of hydrogen or nitrogen that we talked about. And then over time, as more infrastructure gets built up, then they will be able to start to manufacture their own things out of local materials. And eventually, as the technology for 3D printing gets better and self-replicating robots gets better, then more and more of the stuff that gets needed will be built there. And eventually, there will come this day when the last thing gets sent to Mars, that because Mars doesn't have enough of it, and then Mars will be truly self-sustaining, and we won't really know what that's going to be until we work through each one of the issues. But for the longest time, it's going to be like complicated technology. I mean, you need to have a really big facility here on Earth to, say, build a chip factory for computers or solar panels or things like that. And so I think in the short term, it's going to be, you may send, say, the processor for a robot, a bulldozer. And so all you do is, you make the wheels and you make the structure of the thing there, but you send the computer that will run it. And then over time, you'll be able to manufacture the stuff on Mars itself. So whatever Mars is missing, that's what you're going to be sending until Mars can make it all on its own. Joey. Hey Fraser, love the channel. I was wondering if you think there are planets out there where the gravity is less than that of Earth, which would allow intelligent species to freely jump around in ways that we could only dream about. I love this idea of like intelligent species just jumping around because they've got low gravity, and that's fun. And I think, if we could go to like Titan, we always talk about this, that the gravity is so low, but the atmosphere is so thick that you could fly around. And like, I really want to do that. You could do that on the moon as well if you just live in a bubble. But imagine species that grew up in a place like that. So I guess if you evolved in a world with lower gravity, you would probably evolve with, first probably there'd be a lot more animals that flew around because it would be easier to fly and you could get a lot more done just by flying around from place to place. Larger flying creatures. You could also have, say, larger creatures here on the planet, because like an elephant is about as big of a creature as you can have because of the force of gravity. It's got really thick legs and it's really, the very limits. Maybe dinosaurs, right? That's about it. But on a planet with a lot lower gravity, you could have much larger creatures. You could have creatures that are hundreds of meters tall, depending on how low the gravity is. So things that fly and things that are very large. Or you could have creatures that are very spindly, that don't need to have a lot of a physical structure to be able to support themselves. So you could have things that are like insects but very large, or things that are just made of like gossamer material because they can support themselves. So it would be absolutely fascinating. Man, would I love to just see how life evolves in different worlds. A low gravity world, a high gravity world, a water world, an ice world, different kinds of chemical environments. It's sort of one of my great sadnesses, right? Is that for probably my lifetime, we will have to guess. Even if we discover life, we're just gonna have to guess at what life is like there, because it's so hard for us to send a spacecraft to another world. All right, on that sad note of the things that I'll never see, thanks everyone who put in questions for this week's question show. I love it. I read all your comments and I try to gather up as many of them as I can and answer them here. I'll see you next week.